Hi there, welcome back. In today's video, I'm going to be doing a deep dive on the new SORA text-to-video model, which OpenAI has announced just over a month ago. And I'll be going through all it can do. I will also explain the machine learning behind it. And at the end, I will tell you whether this background I have here is real or not. If you already know, of course, just post a comment in the description and let me know what you're waiting for. Let's dive in.
SORA can generate videos up to a minute long from a text prompt. But actually, that's not the most impressive thing it can do. You can prompt SORA with an image and a text input, and it will animate the image according to that text input. If you have a video that is too short, you can use SORA to extend it. You can also use SORA to edit videos with a text input. In this example, you can see SORA adapting the surroundings of the input video to match the text prompt. Another impressive feature is the ability of SORA to combine videos using seamless transitions. With SORA, you can also simulate digital worlds. While outstanding at first impression, SORA still has a long way to go before it can be considered ready for production. See how the wolves are multiplying from thin air? Or the chair suddenly materializing? When it comes to simulating the physical world, SORA has also clear difficulties. See how this cap floats in the air instead of obeying the laws of gravity? And perhaps the biggest hurdle that OpenAI has to overcome before making SORA available to the general public is the economics. In this channel, I like to go a bit deeper on the AI. So after reading the technical report on the new text-to-video model by OpenAI, here are the key points I extracted from this report. SORA is a diffusion model. A diffusion model can create images from noise and a text prompt. The way diffusion models are trained is that by learning to reconstruct an image from noise, which is applied by some type of Gaussian function that is applied so many times that it is impossible to recognize the original image. And during training, the model is then challenged to remove the noise and reconstruct the image again. The model learns by creating a compressed image of all the images that it was trained on. This is not a normal compression, it's a lossy compression. It's lossy because when you ask the model to reconstruct the image based on a text prompt, it will always come up with something new. Hence why these models are also called generative models. By the way, this compression is often referred to as the latent space, which is in order of magnitude smaller, if you consider the memory footprint, than the actual RGB image. Another really important point to consider is the fact that SORA is a diffusion transformer. But what does that mean? Well, it means that instead of applying the diffusion model to the whole image at once, the image is first divided onto patches. And then the diffusion model is applied individually to each segment. Visual transformers were adapted from large language models and have been a key development and differentiator which helped, for example, DAL-E3 and Stable Diffusion to be as good as they are today. SORA was trained on videos with high definition and in their original aspect ratio. What this means is that there was no downscaling or cropping, which was one of the key points mentioned in the SORA report. Of course, training with full HD videos was only feasible because they were training on videos in the latent space. As alluded before several times, SORA was trained on the latent space. What is new to me is the concept of creating video patches across latent space and time. These are not patches of fixed duration like in other text-to-video models, which typically train on very short video clips up to 4 seconds long. The patches in SORA, they vary in duration. Since SORA was trained on much longer clips, it seems to be able to produce much longer videos up to 1 minute long. versus 4 seconds long when you compare it to other text-to-video models. And these videos also seem to be much more stable because the dataset used by SORA was kept in its original resolution, which was either horizontally at 1920 x 1080p or vertical at 1080 x 1920. This allows SORA to generate videos at different aspect ratios and at different resolution. The other secret sauce in OpenAI's model should be fairly obvious to anyone. It's the massive GPU computational power and the amount of data they must have used to train this model. How many thousands of GPUs do you think OpenAI has used to train this model? Take a guess and post a comment with your opinion. I'll be highly interested in seeing that. Now we've reached the end and it's time for our quiz.
Why is SORA able to generate longer videos than other text-to-video models? According to SORA's technical report, what is behind SORA's enhanced performance?
I hope you found this video informative and I hope you enjoyed the quiz, and I'm looking forward to come back with more in-depth reviews of papers in machine learning, generative AI very soon. If you'd like to watch a video on Wave2Leap at 4K, which talks also about the latent space, why don't you click on the video that you see here in the thumbnail?
Okay, I know you've been waiting all along for the answer, and the honest truth is that this is a real, not made by SORA. I can promise you that, especially the kids, they're real.
Now,
We almost forgot. Don't forget to click and subscribe, okay?
like and subscribe.
Like and subscribe.